Hello everyone, my name's Iman. Welcome back to my YouTube channel. Today we're going to be tackling a practice problem set that relates to our lecture on reasoning and research. Let's go ahead and get started with problem number 1. Problem number 1 says, an experimenter is attempting to investigate the effect of a new antibiotic on E. coli. The experimenter plates cells and administers 1 milliliter of the antibiotic. Which of the following is an appropriate negative control in this experiment? So let's first review what a negative control is. In an experiment, a negative control is a sample or condition that's designed to show what happens when no experimental treatment is applied. It allows the experimenter to establish a baseline, and it helps make sure that any observed effects are specifically due to the treatment. So in this case, the antibiotic. Keeping that in mind, let's evaluate each option. A says a plate with no cells that was coated with 1 milliliter of antibiotics. So this option doesn't involve the E. coli cells, which are the focus of the study. So while it might help to check for contamination or confirm that the antibiotic doesn't have any other unintended effects, it doesn't serve as a valid negative control for studying how the antibiotic interacts with E. coli. So this is not the correct answer. B says a plate with E. coli and no additional treatment. This is a valid control to see how E. coli behaves under normal untreated conditions. However, this represents a positive control, not a negative one. Positive controls demonstrate expected outcomes when no variables like antibiotics are introduced. So this isn't the correct negative control, which means B is not the correct answer. C says a plate with E. coli and 1 milliliter of isotonic saline. Now this option is actually the correct answer. Isotonic saline serves as a neutral substance that doesn't affect E. coli. And administrating this isotonic saline ensures that the effect observed with the antibiotic is due to the antibiotic itself and not just the process of adding liquid to the plate. In this way, it isolates the antibiotic as the experimental variable, and it fulfills its purpose as the negative control. Let's still read D anyway. D says a plate of epithelial cells treated with 1 milliliter of antibiotic. So this option involves epithelial cells, not E. coli, so it's not even relevant to the experiment's focus. Including epithelial cells here would introduce an entirely different system, so it would actually make it inappropriate as a negative control for this study. So D is incorrect. Once again, the correct answer for problem 1 is C. Beautiful. Let's move on to problem 2. Problem 2 says, which of the following would best establish a causal link? Let's take a moment to first redefine causality. A causal relationship exists when one variable directly influences another. For example, administering a drug and observing its effect on reducing fever could demonstrate causality if the drug directly causes the fever to reduce. Now, to demonstrate causality, it's critical to control for confounding factors. These are other factors and variables that might explain the observed effect. This is typically achieved through careful experimental design, such as randomization, which helps ensure that the only difference between groups is the intervention being tested. So let's keep that in mind and let's work through each of our options. Let's start with A. A says a cross-sectional study using survey data for hand washing and colds. This is an observational study that examines data at a single point in time. While it may show an association between hand washing and the frequency of colds. It cannot prove causality because it doesn't control for confounding variables or establish a temporal sequence. So this option is not ideal for establishing a causal link. Let's read B. B says a case control study of an exposure during childhood and development of a certain disease later in life. So this type of study is retrospective, meaning it looks back at past exposures to determine potential links with outcomes. Now, while case control studies can help identify associations, they are not designed to establish causality because they recall on recall data and they're prone to biases like selection bias. Therefore, this option is also not the best choice. Option C says a randomized clinical controlled trial of a new antipyretic drug. Now, this is actually the correct answer. Randomized controlled trials are considered the gold standard for establishing causality. So in this randomized controlled trial, participants are randomly assigned to either the treatment group that will receive the drug or the control group that's going to receive a placebo or no treatment. Randomization minimizes confounding factors, and that ensures that the observed effects are directly attributed to the drug. In addition, randomized controlled trials are often using blinding to reduce bias, and that really helps strengthen their ability to establish a causal relationship. So C is the correct answer, but we're going to read option D anyway. So D says an IQ test where the results are later separated by gender. So this option doesn't involve any intervention or control of variables. So all it's doing is separating and analyzing the data after collection. Without controlling variables or conducting an experiment, this approach is not going to be able to establish causality. So it's incorrect. That means that the correct answer for problem 2 is C. Problem 3 says, an experimenter is attempting to determine the internal energy of a well-known compound. The experimenter cleans the glassware, completes the synthesis, calibrates a bomb calorimeter, and then uses it to measure the appropriate thermodynamic values. One error here is that the experimenter blanked. Let's go ahead and work through our options. A says that the experimenter did not determine if the compound was novel or if the information had already been determined. This is the correct answer. Now, we know before conducting any experiment, it's important to confirm whether the information that's being sought is new or has already been established. If the compound is well known and its internal energy has already been measured by someone else, then the experimenter would be unnecessarily repeating work that offers no new insights. So this kind of oversight represents a really big error in research planning, and it's the correct answer. Now we're still going to work through B, C, and D. B says the experimenter did not have a specific goal at the beginning of the research. Now, this option is incorrect because they clearly had a specific goal. Their goal was to determine the internal energy of the compound. So B is incorrect. C says the experimenter should not be involved in both the synthesis of the compound and later testing. This option's also incorrect because there's no rule or standard in experimental science that prohibits a researcher from performing multiple roles like the synthesis part and the testing part. In fact, many researchers regularly synthesize and test compounds themselves. So C is incorrect. D says the experimenter should have calibrated the calorimeter before the synthesis of the compound. Now, while calibration is an essential step, the timing relative to synthesis really doesn't represent an error. So this answer choice is also incorrect. Once again, the correct answer for problem 3 is A. Problem 4 says a researcher wishes to generate a parameter for the mean weight of residents of the US. Which of the following is the most significant concern? A says measuring a person's weight may have psychological consequences and is unethical. B says gathering all of the necessary study participants would be prohibitive. C says knowing the average weight of US residents doesn't provide any useful information. And D says enough studies have already been conducted on this topic to render it unnecessary. Now, looking at option A, while measuring someone's weight may raise concerns about psychological impact, these concerns can often be addressed by obtaining informed consent and making sure that the participants are treated respectfully and that their information remains confidential. So this is not the most significant concern for this study. Option B, however, this is the correct answer. So to determine the true mean weight of US residents, the researchers would need to include every individual in the population. And this is practically impossible due to the size of the US population, in addition to logistical challenges and financial costs. In practice, actually, researchers rely on smaller, representative samples rather than attempting to measure the entire population. So if you were attempting to measure the entire population, that would in fact be prohibitive and it would be the most significant concern. So B is the correct answer. C is incorrect because the average weight of US residents can actually provide a lot of valuable insight for public health, for policymaking, and also for research. It can also help identify trends in obesity and or malnutrition. D is incorrect because this is not really a valid concern. It assumes that the researcher is unaware of existing data. It also assumes that the mean weight of residents in the US stays the same year after year. So if you collect it one year, you never have to collect it again. And that's just frankly incorrect. So the correct answer for problem 4 is B. Problem 5 says a cross-sectional study in which current smoking status and cancer history are assessed simultaneously cannot satisfy which of Hill's criteria. Hill's criteria are a set of principles that help determine whether a relationship between two variables is causal. Among these, some key criteria include temporality. This says that the cause must precede the effect. Another one is strength. A stronger association between variables makes causation more likely. Coherence says that the relationship should be consistent with existing biological and scientific knowledge. And the plausibility criteria says there must be a reasonable biological mechanism explaining the relationship between the variables. So now that we understand Hill's criteria, we can connect this to the study design in question to see which criteria is not satisfied. We're told this is a cross-sectional study, and cross-sectional studies are observational studies that measure variables at a single point in time. These studies are useful for identifying associations between variables, but their design limits their ability to establish causation. Specifically, cross-sectional studies do not provide information about the sequence of events, meaning they cannot determine whether the cause occurred before the effect. So keeping that in mind, the criteria that is not satisfied is going to be temporality, because this criteria says that the cause must precede the effect. 5 is D. 6 says, after randomization, it is discovered that one group in a study has almost twice as many women as the other. Which of the following is an appropriate response? Randomization is a method that's used in experiments to evenly distribute participants across groups in the hopes to minimize the impact of confounding variables and ensure that the groups are comparable. However, Randomization does not guarantee perfectly balanced groups. Small imbalances like that in gender distribution can occur due to chance, and that does not automatically mean that the randomization was flawed. So let's keep that in mind as we evaluate each option. A says move men and women between groups manually so that they have the same gender profile. Now, this option is inappropriate because manually adjusting the group introduces selection bias, and that's going to undermine the integrity of the randomization process. Remember that the goal of randomization is to avoid human interference. So this is not the correct answer. B says, check the randomization algorithm. If it's fair, continue with the research. Now, this is actually the correct answer. The first step when you notice an imbalance is to verify that the randomization algorithm was implemented correctly and without any bias. If the algorithm is functioning like you expect it to, then the imbalance is just likely due to chance, which is acceptable in a randomized study. The researcher can just go ahead and proceed with the study, and the results are going to be statistically valid still. Now, that's the correct answer. Let's still work through C and D. C says eliminate all of these subjects because of potential bias and randomize a new cohort. So this option is kind of extreme and it's really unnecessary. Eliminating participants is going to waste your resources, it's going to waste your time, and it's unlikely to resolve the issue since another round of randomization could very much result in a small imbalance again. So, if the randomization process was valid, there's really no need to discard the cohort. So C is incorrect. D says keep the current cohort and then continue randomizing subjects until the gender profiles are equal. Again, this kind of approach really undermines the principle of randomization. So by you actively altering the composition of the groups, you're introducing bias, and that's going to affect the validity of the study. So D is also incorrect. Once again, the correct answer for problem 6 is B. Beautiful. 7 says an experimenter is attempting to determine the effects of smoking on very low birth weight and the effect of very low birth weight on IQ. Which of the following statements is correct? 1 says smoking is an independent variable. 2 says smoking is a dependent variable. 3 says very low birth weight is an independent variable. And 4 says very low birth weight is a dependent variable. Let's start by reviewing the definitions of these variables. An independent variable is the one that's manipulated or categorized to observe its effect on other variables. It is the cause in a cause-effect relationship. A dependent variable is the outcome being measured in response to the independent variable. So it is the effect. Now let's examine the two parts of the study. First, the experiment is investigating how smoking affects very low birth weight. In this relationship, smoking is being studied as the cause, and that makes it the independent variable. And then the effect being measured is very low birth weight, which is the dependent variable because it changes in response to smoking. Next, the experiment shifts focus to determine the effects of very low birth weight on IQ. Here, very low birth weight is now being treated as the cause, making it the independent variable. And the outcome being measured is IQ, which is the dependent variable because it's influenced by very low birth weight. So considering the two parts of this experiment, statement 1, 3, and 4 are all true. So the correct answer for problem 7 is C. Problem 8 says a study is performed on a new medication. Subjects in the experimental group are told about the potential side effects of the medication, while subjects in the placebo group are not. The subjects have no contact with each other, and they do not know in which group they are placed. The side effects end up being significantly more severe in the treatment group when seen by the same assessor physician. This is most likely caused by which of the following? A says physician unblinding only, B says patient unblinding only, C says both physician and patient unblinding, and D says both physician and patient blinding. In clinical trials, blinding is used to minimize bias. The purpose of blinding is to ensure that neither the participants nor the researchers can influence the outcomes based on knowledge of group assignments. Specifically, patient blinding prevents participants from altering their subjective reporting of symptoms based on their expectations. Physician or assessor blinding prevents the researchers or physicians from allowing their own expectations to unintentionally affect the evaluation of outcomes. Together, these safeguards ensure that the study's results are objective and that they are reliable. Now, in this scenario, the participants are blinded. They do not know whether they belong to the treatment group or the placebo group. This means that any subjective reports of side effects from the patients should not have been influenced by group assignment. However, the fact that the side effects are reported as significantly more severe in the treatment group suggests that the blinding of the physician who is assessing the patient and who told the patients in the treatment group about the side effects may have failed. When physicians know or suspect a participant is in the treatment group, then their expectations about the medication side effects may subconsciously influence how they assess or interpret the severity of the symptoms. This phenomenon is known as observer bias, and it occurs when the assessor's knowledge of group assignment skews their evaluation of the data. Now, the bias that's seen in this study, it's unlikely to come from the patients because their blinding remains intact. They don't talk to each other, so they're not made aware of how one group was informed about symptoms and the placebo group wasn't. Instead, it's the physician's knowledge or assumptions about group assignments that are the most plausible explanation for the observed difference in side effect severity. The physician's expectations about the treatment group experiencing stronger side effects aligns directly with the bias that's present in the assessment. So that means that the correct answer here is going to be answer choice A. Let's move on to problem 9. Problem 9 says, as part of a graduate program entrance exam, a student must submit a grant proposal for a scientific investigation. While the student's hypothesis is well formulated and the student has some preliminary data, the student's proposal is rejected, with the committee reviewing the proposal, citing several articles that support the hypothesis. What mistake did the student make in drafting the proposal? A says the student did not formulate a testable hypothesis. B says that the student did not spend sufficient time reviewing existing studies. C says that the proposed study did not adequately test the hypothesis. And D says that the student did not have enough preliminary data. Now, in the question stem, we're told that the proposal is rejected because the committee cites multiple articles that already support the hypothesis. So this indicates that the issue here is with the student's literature review process. We know in research that a thorough review of existing studies and literature is really important to make sure that the proposed investigation actually adds new knowledge to the field. So they did not do this prior literature search before going ahead and proposing a hypothesis and collecting data and writing this up, which means that the correct answer here for problem 9 is B. The student did not spend sufficient time reviewing existing studies. Problem 10 says a new study of a weight loss drug uses a radio advertisement to generate study participation. What type of error is most likely to result? This is a good example of selection bias. So selection bias occurs when the method of recruiting participants leads to a sample that's not representative of the target population. In this case, using a radio advertisement to recruit participants is likely to attract individuals who are actively seeking weight loss solutions. These individuals may differ significantly from the general population in ways that could affect the study's results, like motivation levels, baseline health conditions, or even previous experiences with weight loss. So this introduces bias because the sample doesn't reflect the broader population for which the drug is intended. So the correct answer here is B, selection bias. Problem 11 says, a researcher designing a study has paid for it to be professionally translated into several languages. The researcher discusses the potential risks and benefits with each participant and allows them to bring documentation home for review before committing to the study. This researcher has put special focus on blank. In this question stem, we see that the researcher has ensured clear communication through professional translations, and that the researcher has provided sufficient time for the participants to review and consider their involvement. So the researcher clearly acknowledges and protects the participants' autonomy and rights. This falls under the principle of respect for persons, and that makes the correct answer for problem 11, answer choice C. Respect for persons by acknowledging the subject's perspective and rights. Moving on to problem 12. Problem 12 says, which of the following methods would be most appropriate for an initial assessment of hemoglobin saturation during an experiment about breath holding? A says, a pulse oximeter, which uses a small light on an adhesive bandage. B says an arterial cannula, which permits repeated blood draws with a single puncture. C says repeated vena puncture because a single puncture would cause data overlap. And D says a Swan-Ganz catheter inserted through the femoral artery, which can measure saturation nearest the heart. The key to answering this problem is by thinking about the ethical tenets we covered in lecture, specifically the principle of beneficence. This emphasizes minimizing harm and maximizing benefits in research. The correct answer to this problem is using the pulse oximeter. The pulse oximeter, it's non-invasive, it's painless, and it's a really efficient tool for monitoring hemoglobin saturation. It's going to provide accurate and continuous measurements without causing any discomfort or introducing unnecessary risk to the participants. The other methods, in contrast, are invasive, they carry greater risk, and they're just not justified for an initial assessment. These methods introduce potential harm, like an infection, or the potential for an infection, or the potential for significant discomfort, which violates the principle of beneficence unless absolutely necessary. So, all things considered, the pulse oximeter is going to be the most appropriate choice for this initial non-invasive assessment. That means that the correct answer for problem 12 is A. Problem 13 says, a medical student attempting to impress an attending physician refers to a recent article that says that there is a statistically significant difference in pregnancy length with a new therapy. Which of the following is most likely to be a valid criticism of the article? A says medical students usually reference articles in the newest journals, which may be unreliable. B says the effect doesn't change patient outcome only a secondary measure. C says there's a lack of internal validity in the results despite significance. And D says selection bias is inherent in the scientific process. The way to approach this problem is to recall that statistical significance does not always imply clinical significance. So in this case, if the observed difference in pregnancy length does not translate into actual meaningful changes in patient outcomes, like improving maternal or neonatal health, then the study's findings may not have practical value. Secondary measures like pregnancy length can sometimes be important, but if they don't directly impact clinical decisions or patient care, then the therapy's utility remains questionable. So considering all that, the correct answer for problem 13 is going to be B. The effect doesn't change patient outcome, only a secondary measure. Now let's move on to problem 14. Problem 14 says which sample would be the most appropriate participants for a study on hormone replacement therapy for postmenopausal symptoms. Now, samples should always be taken from the target population or the population of interest. So, given that the target population is postmenopausal women, that's the group that should be used for the sample, which means that the correct answer for problem 14 is D. Now we can tackle our last and final problem. Problem 15 says, use of a colorimetric assay to determine protein concentration may be subject to all of the following except. A says the use of standards. It will be subject to the use of standards. Proper standards are required to calibrate the assay for accurate quantification. B says measurement error. It could be subject to measurement error, error in pipetting, in reagent preparation, or instrument sensitivity. This can all impact results. C says the Hawthorne effect. Now, the Hawthorne effect refers to changes in behavior by individuals who know they are being observed. This is particularly relevant, as you guessed it, in studies involving human participants. Since a colorimetric assay is a lab technique for measuring protein concentration, it's clearly not influenced by human behavior, and so it's not subject to the Hawthorne effect. C is the correct answer. Now let's still work through D. D says systematic error. This can be subject to systematic error. Systematic biases like incorrect calibration or consistent operator errors can affect the assay's accuracy. So once again, the correct answer for problem 15 is C. Because the Hawthorne effect does not apply to non-human lab processes, C is the correct answer. And with that, we've completed this practice problem set. I hope that it was helpful. We have one more chapter to go for this playlist. You're doing amazing. Keep it going. Let me know again if you have any comments about the questions that we solved in this problem set. Other than that, good luck, happy studying, and have a beautiful, beautiful day, future doctors.